All right, so we'll try to go as quick as possible so we can get to beer. But I'm Brad. I work on the Go team. It is actually, I realized like 30 seconds before I came up here, that is my 5-year Go birthday. So happy Cinco de Mayo birthday to me. So I've worked on lots of the Go standard library and the build system and various like code review tools and things that kind of keep the Go project running. So this is a talk about the Go build system, where it started, where it's kind of currently at, and where it's going. So build.golang.org is our CI system. For every time we have a commit, we want to build it and run all the tests, and we want to do it for every architecture. So it started just before I joined the Go project from Adam Langley, who does all of our crypto stuff, and he checked in this little App Engine app in the MISC directory, MISC dashboard, and he had an App Engine app and a little builder shell file and build control. And it looked like this. As you can notice, it has all the architectures, both 64-bit and 32-bit Linux. So what else do you need? But in addition to just doing every architecture, we also want to do every OS. And we want to do every config of an OS or version of an OS or distro. And we also want to do sub-repos, so not just the main Go tree, but we also want to build our like crypto and net and image repos. And not only do we want to build those for every architecture and OS, but we also want to build those for each of the above, plus all the recent Go commits and all the previous Go stable releases, so we don't like accidentally depend on some Go 1.5 feature and break all the existing Go 1.4 users. So in 2010, the dashboard looked like that at the beginning of the year. Later, we chopped up on our web design skills, and it looked like that. Notice we have Mac now, and we have the beginning of native client support, which is was there, and then it died, and then it came back, and it died, and they kept changing it, but it's back again. We also had an ARM builder. This was a Motorola Zoom tablet, I think, that was running on my desk. In 2012, now it's looking even sexier. We have little bars between operating systems. We have ARM now. This may or may not be the same Android ARM Zoom builder, but we have Windows. And there's some failures, and you can click them and see failures. We're also now building sub-repos, so we can see the crypto and image and net. As of yesterday, it now kind of looks like this, which you may or may not be able to read up there. If not, these are the operating systems we build for. There's one that's just compiles things. There's a whole bunch of Mac and FreeBSD and blah, 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 blah. So this is a partial list of our current builders. One that just compiles, Android, there's ARM and ARM64. You need both of these for Darwin ARM for iOS support, which is coming in Go 1.5. Various 386, 32-bit, and 32-bit without SSE instructions, ARM5 without like Neon and fancy newer ARM stuff, ARM64, PowerP64, both big endian and little endian, all the different variations of native client, all the 64-bit builders that support the race detector, Solaris, Plan 9, Dragonfly BSD. Has anyone heard of Dragonfly BSD? That's actually, I asked at like a sysadmin conference. So, anyway, despite this being a CoreOS thing, this does not all run in containers. I'm not sure how you would run half this crap in containers anyway. So it started out just being an App Engine app, and every machine basically connected to the App Engine app and pulled it for stuff. And because App Engine can't do outgoing stuff, or at least it couldn't in 2010, it couldn't pull Git to even see if there was extra work to do. So instead, one of the builders was kind of just blessed as a commit builder, and it would pull at the time there was Mercurial. We weren't on Git yet. It would pull Mercurial, and if it saw new work, it would tell App Engine, by the way, there's new stuff there. So the state of the CI system was all stored in the App Engine's data store. It was, big tables all the way down. And all the builders were kind of just machines where we log into it and maybe in a screen session run something like that. Really reliable. So there was limited capacity. A lot of them were running in Australia where it gets hot in the summer, and the volunteers running them, Dave Cheney, he would have to turn them off for a while because his house was getting too hot, the machines were getting flaky. We didn't have enough capacity, so we couldn't do pre-submit test runs. We could only submit something and then find out that it broke, OpenBSD or Windows. And then we'd have to fix it after the fact. It would be nice if we could submit something and then, or we could, during code review, we could make sure that it didn't break anything. And we also couldn't run it on the Google Corp network because it could have malicious code. And especially for contributions from the community, we don't want to run it on Google's Corp network. So instead, we ran it on Google Guest Wi-Fi. And it ran a little agent that dialed out and ran SSH dash capital L or capital R or whatever it is and does a reverse little proxy. And so then we could access these things and SSH into them even though they were just sitting on a desk somewhere. And so we did this for like Macs and we did this for various ARM boards. And yeah, one of them was running on like, we destroyed so many Android devices running Linux ARM, and we put Debian on these Android devices and destroyed their SD cards. Then we had Intel SSDs plugged into them and showing up as being the root file system, so they would last longer. And anyway, it's all very janky. In addition to like that sort of jankiness, we also had VMs all over the place. So we had Linux builders on EC2, or a Linux builder on EC2, Windows 32-bit on EC2, and a 64-bit one on Rackspace, because at the time, their EC2 didn't support 64-bit Windows. And then a lot of them didn't support BSD, so root BSD did VM hosting of the BSDs. And also all of these were just kind of screen sessions running things. Or for Windows, we would log in and command.exe had a little loop going. So kind of trashy. So what we really wanted was kind of a descriptive hermetic build environment, because we were always forgetting like where machines physically were and who owned them, and we would forget IPs or passwords. And we wanted, Tribots, so we wanted to test commits before we submitted them. And also, when we broke OpenBSD or Plan 9, it would be nice to actually test your fix and maybe interactively use it, even though you don't have an OpenBSD or Plan 9 or Solaris or whatever. So we wanted to be able to, like, any developer should be able to spawn one of these up and hack on it and then destroy it. So we started with the Linux builders because Linux is easy. So I wrote Docker files for our main environments. And then we had this new binary called the coordinator that basically runs every build in a Docker container and it reports the results to the dashboard. So that covers a lot of them, not all of them, but it covers even like the native client ones because it runs under that. Docker files are kind of what you would expect. Debian, we had some Ubuntu ones, and I think maybe some Arch ones, or maybe that wasn't done. And then here's my obligatory CoreOS slide. We ran, or we still run, the or the farmer.golang.org, which is the coordinator. And we run that on CoreOS, and we have this little script create.go to bootstrap the whole thing, where we have our, here's our cloud config, and we just say, slurp the coordinator, some static Go binary, and run it. And this does an RPC to Google Compute Engine and creates the instance. It's 300 lines of code, including like the OAuth token caching. And empirically, we bought the biggest VM we could at the time, 16 cores, and empirically we found we could do about 6 builds on it before they kind of started crapping on each other. So that was okay. 6 was better than the 1 or so we could do before. And at least now we had a description of our environments rather than hand-configured everything. But for non-Linux stuff, we couldn't use Docker. So for those, we decided to make what I called the buildlet. And it was basically, we wanted every VM to boot and run this web server called the buildlet that speaks an HTTP interface to get files, put files, and execute files. Basically, the least secure server in the world. This is like any remote code execution. And so it accepts a tarball at one URL, it gets a tarball, it gets files, and runs things. It can delete the world, it can reboot the machine. And it's all written in Go, so we can cross-compile it to everything. And so we create VMs that just run this on boot as quickly as possible, and then we can control it remotely from the coordinator. So Matthew Dembski got the party started. He wrote a little script. We have it here, OpenBSD, and he slurps down the ISO from freebsd.org, and then he modifies some stuff in the CD image, and puts this thing to run up boot, and modifies, patches the ISO file, and then he runs it through expect, and it runs with QEMU and console, and kind of types in all the stuff. What's the root password? Root. And then at the end, it craps out a block device, and now we have an image that's bootable in GC. So, but the notable thing is we don't even bake in the buildlet because we wanted to evolve the buildlet binary independently of the VM image. So instead, we set the GCE metadata, and we set a buildlet binary URL. And so each one of these VMs actually, on boot, looks at its metadata environment, slurps down a binary, makes it executable, and runs it. And that's the only thing that VM does. So we did that. And then somebody else, Bill Feed, did FreeBSD. David Ducolombier did Plan 9. We ended up having to actually fix GCE and Plan 9 to do this because there was networking issues and everyone was at fault. I did Windows, which was a lot of pain. It involved basically, instead of a Docker file, notes in English, disable this, click this, right-click this, go into user control passwords, make that the auto login user. Yeah, it's just tons of pain. You had to disable security updates. Anyway, but now we have this directory that has all of our build configs, whether they're Docker files or scripts to create FreeBSD or OpenBSD. So that's nice. So now we could run 200 or whatever our quota was at the time VMs on GCE, and if we needed more, we would just file a ticket and ask for more quota. And but we can only run 6 Linux ones at a time because we were on a single host. And so that was sad that 6 was less than 200, and Linux no longer could keep up with the Windows builders. So I wrote Docker to boot, which is kind of a joke name on boot to Docker. And it takes a Docker file, and it smashes all the layers down and makes a bootable VM. And that VM, or VM image, doesn't actually have Docker in it itself. It has an initrd and a kernel, and it boots up. And so now we've simplified our world, so instead of having a Docker and VMs, we only have VMs, and we only use Docker for the Docker files. So now we can, everything looks the same. It's kind of a hack, but it was fun. And now for developers wanting to hack on stuff, we have a little tool called gomote. You can create different VMs, even if you don't have it, and you could sync your file system, your Go tree to it, run commands, and destroy them. So this little demo, I could say like gomote or gomote create. And this is just an interface to the buildlet, and I can see all the things that I can create, or I can say gomote list, put it at the top. And those are some things I have, and I could say, push to Plan 9. That syncs my local file system against it, sends the minimum delta. Okay, it's all fine. And I can say gomote run go source all.rc, and then I could run the full build on a remote Plan 9 machine. And so it actually streams all the output over standard out and standard air. And wait, who has heard of HTTP headers? Probably everyone. Who has heard of HTTP trailers? Yeah, no one really uses them. They're not implemented anywhere except for in Go, in the server and client server. It's basically HTTP headers at the end of the body. So we send the remote command's exit status in the trailers. So when this thing ends, you can actually look at the exit status correctly. So for fun, we can go in and modify some Plan 9 thingy and say exit, oh my god, a string. In Plan 9, you don't have exit numbers, you have exit strings. So we could push that to Plan 9. And so all.rc or all.bash or all.rc or bash.bat.rc are the Windows Plan 9 and Unix build things. So now it synced that up, and if I push it, whoops, I already pushed it. If I run, we should see it failed. So it's cool. I fixed a number of Plan 9 issues, even though I've never used Plan 9, that I could kind of interact with this machine. Notably, Plan 9 also doesn't have SSH, and Windows doesn't have SSH, so this is kind of a least common denominator interface to work with lots of machines. So yeah, gomote is fun. As for OS X, we can't legally run VMs on AWS or GCE, and this isn't really a technical restriction. This is an Apple legal restriction. But Apple's whatever EULA lets you virtualize OS X as long as it's running on Mac hardware. So we got a bunch of Mac Minis and attached iPhones and iPads to them and put them in a data center. So then we could run a little Go program on the OS X machines, which is a little Go program API server to create VMs, and you could run VMware's VMrun. Somebody else in the community did this. We're just about the stage of deploying this, and it takes about less than a second, or less than a minute, just a couple seconds short of a minute to boot a VM from VMware up to OS X, 10.10 or 10.9 right into the buildlet. So we're planning on doing builds on all 10.7, 8, 9, and 10.10. So then in the coordinator, we made a little Go interface called get buildlet. Basically, anything that knows how to instantiate a machine, a container, a VM, whatever, can return that. So then we started implementing, in addition to like creating VMs on GCE, we made the reverse pool that lets other idle machines dial into the build coordinator, which is our farm.golang.arm, farmer.golang.org, and you can see like the reverse pool. Oh, we're still racking some of them, so we have one of one currently idle. And so we're using this for OS X and PowerPC 64 and some weird things that have no other possibility. So we get physical machines and have them dial in. So we use GCE for all the x86 things that run there. We run the reverse pool for anything that we basically can't run on. Solaris has like no VirtIO net or something, VirtIO SCSI driver. So that one will be reversed probably soon. We're going to do an AWS one. We used to be on AWS partially, but we'll probably go back to AWS now that we have this interface because they let you run really ancient Windows versions. And we want to be able to run like Windows XP in 2003 and stuff like that that GCE doesn't let us do. We'll probably also start using Kubernetes since they could probably get a container up and running faster than GCE could boot. GCE is pretty fast, but it's variable. And there's this new company, Scaleway, or online.net, that does ARM hosting. Or they're not VMs, they're like physical ARM machines, but they have tons of them. They let you provision them in like 44 seconds, they claim, on their website. So we also now have Tribots integrated with Gerrit with our code review system. So when we're reviewing, we can say run Tribot. And then it can review, it could reply and say, I like this one. 11 of 14 Tribots failed, and it lists all the ones, and it included links to all their failures so you could look at them. And then David replied here, he's like, all previous comments addressed, all were on point. This time for sure for getting it to pass the Tribots. And he sends patch set 2, Tribots begin, and you can watch them in real time. It failed on one of them, and it replied. So he's, they're helping out development, so our tree is less red now. So now basically the picture looks like this. We still have build.golang.org. Build.golang.org is this page. This was just from a second ago. You can see if it's currently building, it's this little gopher thing. This may reload. That's the ARM64, so that's running on an iPad or something. I wonder if we could actually watch it. Yeah, so you can see it's this is some iPad that's running in Atlanta or something. Oh, it's another line coming in. So it streams to the browser right from the thing through the coordinator. And then, yeah, so that's the farm page. This is all the builds that are currently in practice. There's only 2 active right now, and the Tribots are idle. But sometimes this spikes up to hundreds. So the state is still here. The farmer pulls build.golang to see what there is to do. There's a little Docker container running under the farmer, like getting stuff. Pulling Git and Gerrit for like Tribot state and doing API requests to VM providers to create VMs. And then there's pools of machines over here doing weird things. Some random screenshots. Here's when it was doing 60 builds and watching the output stream. Here's GCE showing a lot of VMs running, or some starting up, some running. So you can see like Plan 9 and OpenBSD and native client and Windows and. So that's about it. We can do a combination of demos that may or may not work and questions. Or we just skip straight to beer. I wanted to show, I was going to clear something on the dashboard here. So we have a tool to reset some of these, because sometimes we have some build configuration wrong and a whole thing goes red. So we have a tool to clear the red. But I was going to just pick one of these things and clear it so we can. I think I was clearing Linux, AMD, one of these. So retry builds. And so now if we reload this, you can see there's a hole there. So that hasn't been picked up by, it's not OK, it's not a failure. We just reset the data store. And now you can see the little gopher is there. So now we can click that. You can see that it's still. It requested the instance to be created. It waited 0 seconds for quota. This is the instance name it'll be running on. It's creating the instance. So this is where it would be nice to have Kubernetes to have, at least for Linux, have really quick containers. So time from the time we do the RPC to create a container to having the buildlet running. Right now it's, OK, the instance was created. So it took GCE 27 seconds from the time it said it was there to. And now it's just the Linux boot up time, which should be less than 10, 15 seconds. We've stripped down our user space a lot, so it doesn't do much. In fact, there is almost no user space because it was just this Docker file that we had. We actually have to add stuff to our Docker file to make it bootable. So show that, yeah, there's the little run Tribot thing. Any questions while my demo starts up? I can't really see anything anyway. Well, anyway, I think that's about it. Maybe this will start up in a second here, but you can hit it yourself too. You can just go to farmer.golang.org or build.golang.org and watch. But anyway, thanks.